Hi. Today's lesson is going to be on Python data types. More specifically, what are data types in Python and how they can be used. In this lesson, we'll cover declaring and initializing a few variables. Variables are where we store data of different types. For example, the types that we'll cover are bool, where you can store a true or false value. The int, where we can store whole numbers or integer values. Float, where we can store floating point values, things with decimal places, or numbers with decimal places. String, where we can store a list of characters or a word or a sentence if you need, to store that inside of a string. We're also going to cover collections of bools, so like a list of bool, and we're also going to cover a list of string. And let's get started. All right, so what we have here is our basic hello live lessons. We have a main function here, and we have a call to that main function at the bottom of the Python file. So when I run this, it should just say hello live lessons on the right. Awesome. All right. The first variable that we're going to cover is a bool. So basically with the bool, we can declare a variable, but we don't have to actually put the type on it. So we're going to declare our first variable as is lesson started, and we're going to say the lesson is started. We're also going to print the lesson started value, which is going to print as true. So basically we want to say lesson started, and we're going to use something called interpolation with strings. I'll speak more on this later. Basically, that's all we need for that part. And then we just use the percent sign to give the values to the string interpolation. And our value is lesson started. So when I print this, it's basically going to show the lesson started value and then true on the right hand side of the lesson started title. Awesome. Okay. So that's basically how declaring a Boolean works. We're also going to cover Boolean expressions. So another Boolean that we're going to have that we need is lesson ended. And the lesson has not ended yet. So we are going to use is lesson ended, and when we print this, it's going to print false. So at a later point, I'm going to add in Boolean expressions to this variable where you can check whether something is greater than or less than some other value. You can check if another variable has a true value inside of it already, but we'll get to that soon enough. All right, so moving along to the int type, I want to declare an int that is called total number of runs. And this int is going to be the value of 5, a whole number of 5. And we're also going to have another integer value or variable and it's going to be called expected number of runs, and that I'm going to initialize to 10. No, I'm sorry, 15. All right. And we're going to do one more thing with another data type. We're going to use the float type now. When we calculate an integer with a float, it automatically becomes a float. So here's an example of how that works. So we're going to have another variable called sum1, and we're going to take the total number of runs, and we're going to add 2.0 to it. Oh, I spelled it differently. All right. Yeah, so we're going to take the total number of runs and add 2 to it. And then we're also going to have another sum of sum2, and we're going to add 2.1. All right. So let's go ahead and show those sums on the screen or in the console. Print sum1 and interpolations. Okay, so we're going to do an interpolate. Actually, let's do it a little different this. Yeah, let's do it a little different this time. We're going to do sum1 here, and we're also going to do a sum2 here. Okay, so basically what we have are two different ways to use the string type. We'll speak more on the string in just a moment, but there's interpolation and then there's concatenation. So basically this is a string and then this is a float value because of this 2.0 that's added to the integer value here. And basically, we're going to print out sum1, which is going to be 5 plus 2.0. So when an integer is added to a float, the result of that addition comes out as a float. So this sum is actually going to be 5 plus 2.0, which is 7.0. And sum2 is going to be 5 plus 2.1, which is 7.1. So let's go ahead and run that and see what that looks like. Oh, what did it say? Oh, I have to use interpolation. Or, yeah, I have to use interpolation. All right. Yeah. Okay. There is a way to make this into a string. I could put it inside of the string with the, you know what, let's do it the other way. Let's do the formatting string, and let's have the sum1 inside of the formatted string. Right. And then we're going to have sum2, sum2. So, I'm on a roll. Okay. This works. Why try to fix something that's not broken? All right. So this is how the floats can be interpolated into a string. Basically, you convert it into a string here by using the %s. The same thing happens with a bool. We interpolated it into a string. We basically turned it into a string. and we printed it out as a string. So the same thing happened here. Our lesson started true is all one string now, and someone a colon 7.0 is all one string now because of the interpolation that happens here and here. All right. So the next section is going to go into strings in more detail, but more over the operations of a string, where we're going to have an evaluation. And this evaluation is going to be a single quoted string. Technically, there's a slight difference between the single quotes and the double quotes, but you can basically still do the same thing with the single quotes. It's still a string in Python. So the word evaluation is going to be the value of this variable. And we're going to create another variable called adjusted. And this variable is going to be the evaluation adjusted. So the first operation that we're going to take on a string is to replace. And we're going to replace every A in the word evaluation with an O. And also, we want to print. So let's go ahead and print the evaluation and interpolate it again. And yeah, it's going to be evaluation. Okay, great. All right, so we have the evaluation. Then we also have the adjusted. All right, so with the adjusted, we're going to print out the new version of the word evaluation with all of the A's removed and replaced with O's. Also, we want to note that we're not actually changing the evaluation string because in Python, the strings are immutable. And when we call replace, we're actually replacing a new string's value. So we're creating a new string from evaluation. And then with that new string, we're replacing the A and the O within the new string. So adjusted is actually a totally different string. So this is why when we print evaluation here, it's still evaluation when we print it out. It's still evaluation when we print it over here. So evaluation. And the reason why is because this string was never changed because it's something called immutable. Name evaluation is not defined. Today is going to be rough. Okay. So yeah, we have the evaluation here, and then we have the adjusted. So with the adjusted, notice that the A from evaluation has changed to an O here, and also here, where the A was there as well. We're actually pretty close to spelling an entirely new word. And I want to move forward with that idea. So let's go ahead and create a new word. And if we were to replace in the word evolu. Oh, something is wrong. All right. If we were to replace one of the characters in this word here, we could actually make an entirely different word. More specifically, if we took out the O here, we would have EVOLUTION, spelling evolution. So let's go with that. Let's go ahead and create a new variable called evolution. And it's going to take the adjusted value, and instead of replacing, we're going to do something called a substring. But in the syntax of Python, you can actually substring with the brackets, basically saying that the string value is a sort of array, which it is because it's basically a collection of individual characters. So the first position of a string is character E. The second position of the string is character V. So this is a collection of characters all added together. So basically it's an array. So the way that we can access a smaller portion of the array, because the goal here is to make the word evolution, we can say we need to take a few of these characters in the beginning, but leave some of the others off. So to do that, just as an example, if we were to give the starting position of a new string, a new substring, 0, and then the ending position of the new substring 2, it should give us the position, the characters of E and V. All right, so let's test that out. Evolution, and let's take this variable and print. Okay, great. So the way that it works is basically the second number that's added within the brackets after the colon is basically the stopping point. So if you wanted to do like a smaller version of a string, you could say start at 0 and end at 2, and you'll get the letters of EV, but the positions in the string are 0, 1, and 2. So 2 is actually the O. So when we say 2 as the stopping point, we actually exclude that stopping point. Keep that in mind for the next part, because to make the word evolution, we can basically grab all of these characters here. So we would grab 0, 1, 2, 3, 4, and 5. And if we exclude the 5th or the last position, then that O is kind of gone. It kind of disappears if we continue past that point. So let's go ahead and say 5 here so that we can get EVOLU. But it's going to leave off the O because this is the stopping point and also the exclusion point. All right. Okay, great. So we have EVOLU, and then the stopping point was the O, so we left it off. All right, so the next thing that we can do to finish creating the new word evolution is to substring again, or substring again the adjusted, but we can start it from 6 and then basically go to the end. So we don't actually have to put the length of the string to go to the end. If we just put 6 colon, it basically knows that it needs to go to the end of the string. So that being said, we should have the word evolution now. Perfect. All right, so we have EVOLU from the first substring, excluding the fifth character, and then skipping over that fifth character with the sixth character of T, and then the I and the O and the N to basically finish it off. All right, so that is basically how strings work on a surface level. This is what we can cover within the time. Basically, the next section covers a Boolean list, or a bool list. So basically, with a bool list, we're going to create a variable called intermediate bool list. And it's only going to have 3 bool values inside of it. This is just a single variable with a single bool value, because that's just how variables work in general with a single value. But because we're doing arrays and we're using the brackets, now we can have multiple Boolean values. So let's go ahead and create 3 Boolean values of true, false, and true. All right. And what we want to do with this is to print these values. So we'll have, maybe a label that says first bool, second bool, and third bool. And then we'll just access the array the way it's pretty much similar to how we did the adjusted, but we're just going to access a single position within the Boolean array here. So this is what that looks like. So we have a print statement, and the print statement is going to take a string, an interpolated string. So we're going to have first bool, and we're going to create a string interpolation, and then we are going to have a new line in between each one. Yeah. And the second bool is going to be called second bool, and then the last is going to be called third bool. All right, so the only thing left to do with this string interpolation, like we've done before, is to add the variables. Now, because we only dealt with one string interpolation value in the past with these previous usages of the string interpolation, we only needed to put a single variable. But because we're dealing with 1, 2, 3 variables, we need to create something called a tuple, which is basically just a set of parentheses that can hold multiple values inside of it. And that could actually be stored as a single variable as well. Basically a named tuple. But within this set of parentheses or tuple, we're going to put the values of okay, I should take this, put it up here, make it a little bit easier to read, and do that. Okay, yeah, so within the tuple, we want to access the intermediate bool list, and we're going to access position 0. So position 0 is this guy right here. All right, and we're also going to access 2 more positions. We're going to access position 1 and position 2. All right, and just to make sure everything is working properly, let's test this out. Okay, great. So we have first bool true, second bool false, and third bool true. All right, we're going to need 2 of these because we're actually going to change the intermediate bools. We are going to reassign them to different values here. So position 0, we're going to set it to false, and We're going to do the same thing for position 1 and position 2. Position 1 had already had the value of false, but I just want to make all of them false. Maybe at some point you would be using loops, and then you would have access to a list like this, and then you would be cycling through, and maybe in your loop you would have some item here that would change value from 0 to 1 and etc. And then you basically can assign whatever value you need on the right hand side of the equal sign to update those positions in that list. As of right now, we're not going to do expressions with these 3 variables, but we are going to do an expression at the end, a Boolean expression at the end. All right, so now when we run it, it should print first bool false, second bool false, and third bool false after this section prints. Awesome. So we have first bool false and so on. Okay, great. So moving along, the next section that we were supposed to cover is string list. And no, I'm sorry. The next section we were supposed to cover is float list. So float list is basically going to be similar to this. It's going to be a list declared as a variable. It's going to have brackets for an array, and then it's going to have values within the brackets, in between the brackets, separated by commas. It's also going to have printing, and we're going to access them, and then we're going to update them. So let's go ahead and just copy this guy. Okay, great. So we have intermediate float list. And within the intermediate float list, we're actually going to reuse some of the previous values that we already have. And those would be sum1 and sum2. So the first position is going to be sum1. The second position will be sum2. And the third position will be sum1 plus sum2. All right. And we need to change this from bool. So everywhere there's bool, oops, we can make into float. And because this basically just duplicates, we can set this down here the same. Okay. The only thing left to do now is to update the float list. And we're not going to set it to a value. We're actually going to update the value that's already inside of the position, which actually sum1 is 7.0, sum2 is 7.1, and the two of them added together is 14.1. So that's what these values are, 7.0, 7.1, and 14.1 right here in these positions. We'll see that when we print in a moment. But what we're going to do is we're going to update those values. We're going to actually use an operator that does 2 things. It multiplies the value, and then it reassigns the new multiplied value to the same variable that's being used. In this case, the variable is a position in an array. All right, so we're going to multiply equals 2. And we're going to do that for each one of these. All right, so we have the first float, second float, third float, and then we have the values being printed. And then we update those values, and then we print them again after they've been updated. So let's go ahead and run this and see what it looks like. Okay, great. So we have first float of 7.0, second float of 7.1, and third float of 14. What happened there? Something happened there. Why did it give the wrong value? That's odd. I don't think it did this before. All right, so we have the third float of 14.0, and it should be 14.1 because 7.0 plus 7.1 is 14.1. And oddly, both of these, I see why it did that. I didn't change this to sum 2. Okay. All right. That makes a lot more sense. Okay, so sum 1 plus sum 2. For some reason, I thought I typed that, but I didn't. So let's go ahead and run it again now. And we have, okay, great. This is the answer that I was expecting. So 14.1, and then 14.1 multiplied by 2 is 28.2. And the same thing goes for the first float. 7.0 multiplied by 2 is 14.0. And 7.1 multiplied by 2 is 14.2. All right, great. So that works. And now to end the lesson, we want to check for a few things in this last Boolean variable, but we're going to create a Boolean expression. So the first part of the Boolean expression is actually going to be a previous Boolean value of is lesson started. So we're basically going to say if the lesson is started and sum 2 is greater than sum 1. And this should basically print out the last part, lesson ended true. As of now, is false. So the way that this works is lesson started was true from the beginning. And sum 2 is 7.1 and sum 1 is 7.0. So sum 2 is actually greater than sum 1. So this is true as well. So true and true will give us the value of true here in just a second. Okay, great. All right, let's check to see if we have any questions. Looks like we have a couple. The first one is looks like we have a couple. Is that permeating? Let's make sure I didn't break the internet. Okay, great. So the first question is how do you find the type of a variable? So yeah, we have all of these variables and they have implicit types, like they're not actually explicitly typed. So if we wanted to, we could print out the value of what that type is through a function by the name of type. So yeah, so let's say the lesson started type is type with lesson started within the parentheses of type. So this is basically a function called type, and we pass in the whatever object that we're referencing at the time. All of these variables are objects in Python. And the type should print out. So let's go ahead and print what the lesson started variables type is now. Okay, great. So type is a class, but it has a function that actually tells you, well, that tells you what type it is. So in this case, the type is bool. We can do the same thing for the sum. Let's do sum2. So sum2 type, and then let's do type here, type there, right? And that should be float. That type should be float. Okay, great. So we have sum2 type is float. And let's do one more. Let's see, the list. Let's do a type for the intermediate bool list. All right, so print bool list type, and we are going to do interpolation, and we are going to use the intermediate bool list, but we need to use the function type with the intermediate bool list. Okay, let's try this one out. So bool list type. So it says that the type is list. And if we wanted to know what the first position, type of position 0, this should come out as bool, because that's what the value is at the first position, is a bool. So it should say, it should say bool is type 0, and then that type of that position is bool. All right, so hopefully that answers your question. I see one more. Are Python data types classes or data structures? Every value has a type. As you can see, we're just showing a few of them. The string, the Boolean, this Boolean has a type. The float has a type. But basically, like I said just a moment ago, all variables in Python are objects. So technically, they're implementations of classes. They're not actually classes themselves, but the type is a class. The type shows what class it is, basically. So the type of list is the basically list class, and the type of bool is the bool class, and the type of float is the float class. But the object itself is an object. And one other thing I think I mentioned in a previous lesson is that even methods and functions are actually objects as well. You can show that the type of the function. So let's see if I can do a print for the type function type. And %s, and interpolate with type, and we can do, I wanted to do the documentation or dictionary offset. Let's see, class. Yeah, so what you might notice here is that type is a function, but it's also a class. So you can reference the class here. What else? I probably should choose another class. Oops. And let's see, what other functions are there? There's the length, the length function. So len is a function that you can use to get the length of a list and things of that nature. Yeah, so let's do that one down by the list. Right here, so we have bool list length, and we are going to say len here just to show the length, to show that it's actually an integer value and it should be 3. And also we're going to print the class bool list. I'm sorry. Yeah, bool list length class. All right. It's basically just going to say what the class name of the length method or function, length function is. Yeah, so here, the type of the length, excuse me, the type of the length function is a built-in function or method. So yeah, as I was saying, even functions and methods are objects themselves. So you can access objects by saying dot after them. So you can pretty much say dot after anything because they're all objects. Yeah, every variable is an object. All right. Hopefully it says our Python data types, classes, or data structures. So they're basically objects, but they reference classes. Yeah. Hopefully that answers your question. All right. Looks like we're done with the Q&A. So the next lesson is supposed to be on Python collections, such as the list and the map and other collection types. Keep an eye out for that. And also, if you want to suggest a lesson, you can do it here at git.io/JQF3D. Actually, capital J, lowercase q, capital F, 3, and capital D. That is a link directly to the GitHub page, and you'll be able to see what our upcoming lessons are, what our past lessons were, and there'll be links to those in the lesson plan. But also, this is a direct link to suggesting lessons. Yeah. All right. Have a good night, guys.